Right. Well, here we are again. So some examples of hyperbolas. Now we've got here y equals 1 over 2x plus 1. Okay, now pretty much automatically what we should start to be thinking about is what's the domain, what's the range? What's the domain, what's the range? And so let's have a think about that first, of this first one. So I'm going to put domain and range. Now the first question is, well, is there a value of x that I can't have? And of course the main category is when we discussed this a little while ago was, is there anything under a square root? That's not allowed. If it's negative, it can't work. And in the denominator, if the denominator is 0, then it doesn't work. So if we're thinking about the domain, then if I have 2x plus 1, actually I'm going to get rid of this range because that makes it a bit hard to see. If I have 2x plus 1 equals 0, then that's undefined. So what would be the value of x for that? Now hopefully you can see fairly clearly that x is equal to negative a half. So x equals negative a half is a value that I cannot have. So my domain would be, using interval notation, negative infinity to negative a half. That's going to be my vertical asymptotes actually. Union with negative a half to positive infinity, all the way up. I can have 0. If I put x equals 0 in, then it'd be 2 times 0 plus 1. And I would have 1 in the bottom. So that actually tells me something else, which I'm going to come to in a moment. So the vertical asymptote is very closely related to my domain. I'm going to put a little arrow here and put it right here. The vertical asymptote, it's a bit of a hard word to say and to spell, is x equals negative a half. X equals negative a half, all right? Now, I've got my set of axes. I might as well go ahead and put that in. I might use blue or something. And I'm going to put that in as a vertical dotted line, which asymptotes are typically put in as dotted line. X equals negative a half. It's going to be negative 1, 1, 2, 3, etc. All right. Next one. We want to talk about the range. Now, from our previous little activity, is there any vertical translation? Am I adding or subtracting a constant? So the answer is no to that. I've only got horizontal translation because of what's happened in the denominator. So that's already telling me that probably the horizontal asymptote is the same, but let's just double check. So I've got the number 1 in my numerator. On the number 1, is there any value that I could get for x that if I divided 1 enough, I would get 0? And the answer, of course, is no. So my range is negative infinity to 0. The union of that with 0 to all the way up to infinity. And so that's what we have. So my horizontal, not vertical, my horizontal asymptote is again closely related, basically determined by the range, would be y equals 0. And I'm also going to mark that in here. Okay. Now, it is good to note that when you sketch a hyperbola, it's really a sketch. It's not a detailed graph drawing, all right? It's important to note because the shapes basically always look the same. You just have to get the general quadrants correct, any asymptotes clearly marked, any intercepts, and then you're pretty much good to go. Notice that it's positive. It's positive here. There's no negative sign. You should have seen from your investigating that if it's positive, it's going to be this quarter and this quarter. All right? Basically the quadrants, with the asymptote shifting up and down a bit. If it's negative, we'll see in the next example, it's going to be this part and this part. But for this example, it's positive, so we're going to stay here. We're going to stay here. All right. So let's work out a y-intercept. Now for a y-intercept, it doesn't always work, but in this case it does. X is equal to 0. So y would be equal to 1 over 2 times 0 plus 1, which is equal to just 1. Why is that? Because the denominator is 1, 1 over 1. So we're going to put the curve right there. That's a value of 1. Now, there's not really any other point I can sort of mark on my graph. So I've got my asymptotes drawn. I've got my y-intercept. I've clearly put down the values of the asymptotes. Y equals 0, x equals negative a half. Those are correct. I've determined what my domain and range are. And so my hyperbola is going to look something like this. And I've got my y-intercept. It's going to get closer and closer and closer to this. And then it's going to curve around a little bit, and it's going to come down, 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 down. Get closer. Make sure it doesn't turn up and sort of change directions. Like you don't want it looping back up somehow, right? Make sure your sketch doesn't show that. And then the other half, we sort of have to reflect it as best as possible. But essentially, if you showed it in the correct sort of quadrids, I should say, then you're basically going to get full marks. All right, and then of course we label it as y equals 1 over 2x plus 1. All right, so we consider the domain, the range, find the asymptotes, and then find any intercept if possible, and then we go ahead and we find that. Notice though that if we have a constant, I'll just put this note here, constant on top, I should say in the numerator, let's use the proper terminology. Constant in numerator means it's going to be y equals 0 asymptote, right? Like that's basically always going to happen. If there's a constant in the numerator, the only thing that can happen is that y cannot be equal to 0. That has to be the case. So to keep that in mind. Let's jump to the next one. So we've got y equals negative 2 over x minus 2. All right, so let's think about the domain first. The domain. Now, the denominator can't be 0. So we're going to say that x minus 2 equals 0, then that must be x equals 2. Which means that the domain is given by negative infinity to 2, the union with 2 to infinity. So I'm going to go ahead and put my dotted line in, dot, 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 dot. That is x equals 2. So that's my vertical asymptote, I'll just use some abbreviation. X is equal to 2 is my vertical. And my range, I will tell you straight away, you notice that you've got a quadrant here. Not a quadrant, a constant here. That's a constant, so that's my clue that it's going to be 0 is my horizontal asymptote. At this stage in the course, basically we always get zeros, but not always, you've got to be careful about it. But that's going to be negative infinity to 0. We've done this a couple of times now. 0 to infinity using that union notation, which you call interval notation, but with that union symbol, that U. So the horizontal asymptote would be y equals 0 is what we have. All right, now can we have any intercepts? Well, let's check, particularly for y-intercept. We can't have an x-intercept because we know that the horizontal axis is a asymptote, so it's never going to touch that. So when we have x equals 0, y would equal negative 2 over 0 minus 2. What is that? Coincidentally, I did not mean this to happen, but it also happens to be negative 2 over negative 2, which is 1. I perhaps should have thought of this a bit better. But anyway, that's 1 is what we have. So another y-intercept of 1. Let me just add the vertices, the axes label, just to look at it. Now, it is negative. It is negative, which means that we're going to be in this quadrant and this quadrant. Now, not quadrants exactly, like, yes, in case you want to tell me that. It is in that kind of top left, bottom right, because it's negative, not top right and bottom left when it's positive. All right, so it flips around. I'll get rid of these points because that's confusing. They're not actually passing through that. I just have to approach my asymptotes, go through my point of intersection, keep going downwards, don't turn around, and then kind of reflect it back into this one here. And that is y equals negative 2 over x minus 2. By the way, the negative 2 over x minus 2 is the same as a negative out the front of the fraction, all right? Just so you're aware, that's the same as writing it like this. Often we get a little bit confused. It's the same thing, okay? So there we've gone through and listed what the domain is. and the range. The horizontal and vertical asymptotes are clearly marked. Then we have the curve sketched because I've found the y-intercept in this case. Not always possible, right? If my asymptote is a vertical axis, as in x equals 0, obviously there's no intercept. And as long as you get the general shape correct with 2 branches, then you have done it in the way that you are asked to do it. All right? Questions are there. Give it a go. Happy hyperbola drawing. Thanks.